Evet, merhaba arkadaşlar. We will continue the discussion on recursion. So I will do more examples on today's classes. So we're basically going to cover recursion today as well. So if you consider anagrams, they're basically, repeating a certain pattern over and over. That's what an anagram is. And actually, fractal is type of an anagram, and we will see some other implementations in terms of both graphical and also here's a textual or on a string. We have a recursive algorithm. So if you consider the algorithm to write for a given string or a word, you're asked to write all the different combinations that you can generate using the letters. So for example, if you have the word east, you'll basically have how many different permutations of this? How many different words you can write, either meaningful or unmeaningful, doesn't matter. So you will have 24 different combinations, basically 4 factorial, right? So it's basically you rewrite, you rephrase the words and generate new, strings as a result. So if you were to write all different combinations of this word, how would you write it in a recursive manner? So what would be the solution that you can propose to write a recursive algorithm which is going to print out all different permutations of this word? If you're given a single word and you're to write the different combinations. Basically what you could do is take each letter from the word, such as E, and then add all different combinations that you can write with the remaining string, AST. And then similarly you will have the same thing, A, and then you will write all different combinations with the remaining letters, EST, and then you can have S at the beginning, and then all different combinations with the remaining 3 letters, which is going to be EAT, and then you will have T, and in which case you will have EAS. So as you see, in a recursive manner, what you could do is you can write this in the form of 3 new combinations, right? In which case I will have A at the beginning, and then I will write all the combinations with the remaining string ST, and then I will have S, and then I will have AT, and then I will have T and AS, right? Similarly, you will do the same thing for this 3-letter combination, this 3-letter combination, this 3-letter combination. And if you consider this one, basically you will have 2 different combinations, right? You will basically have S and then the T and then T and S. So which is going to, since this is only one single letter, you'll be left with that combination will return you ST. This one will return you TS. And if you generate all different combinations in this way, you'll get a recursive algorithm. So basically, this is the method that you can generate all different permutations of a given string. So in order to perform this, what is the idea? So for each letter, you're going to basically recursively call the same method with the prefix. This is called the prefix with a new word as shown here. So if you see the algorithm, it will be more clear. So let me show you the algorithm. As you see, you have the run method, which is basically going to use the print anagrams, which initially is starting with the prefix empty and then the word that is given. So it reads from the user input a word such as east, and then using that and a prefix empty, since you start with east, right? So you start with east, you have all these 4 choices. It will start with a prefix empty. So there's no prefix to start with, and in each step, prefix is going to be bigger and bigger as you go. So if you look into the base case, obviously the base case, as we did here, is going to be, if you have only one letter, that's going to be your base case. if word.length is less than or equal to 1, you'll get print line prefix plus the word. So what is the prefix? Whatever it has come as a prefix plus the word, which is only 1 character long, and you'll print that whole thing at the end. So in this case, basically the prefix for this one is going to be all the letters of all the combinations of the letters here. It will be E, A, S is going to be the prefix, E, A, S, and then you'll concatenate T, which is the word. So you'll get east. And on this combination, you will have E, and then A, T, which is going to give you EAT, plus the last letter, which is the word eats. And so on and so forth. So you'll get the prefix plus the word. And if you look into the else part, which is the recursive part, basically you have for int I equals 0, so you get the word's length, right? And then, so for each letter in the word, in east, what you do is that I is going to be is equal to 0, meaning that you'll get E. So what's it going to be? The current is going to be identified by word dot substring 0 to 1, right? Current is going to be what? Substring, and then you'll get 0, 1, which is going to be equal to, what is it equal to? E. You're getting substring 0, 1. And then your before is going to be, what is before? What's before? It goes from 0 to I, if I is equal to 0, it goes from 0 to 0, which is going to be equal to an empty string. So there's nothing in there. You're basically getting whatever is before E, whatever is after E. Okay? So this is going to be before, and after is going to be, obviously, if you look into this, after tells you word substring I plus 1, so it gets the remaining part of the word, which is AST, and after will be AST. So if you look into the recursive call, what does it do? It calls the thing with print anagrams, prefix plus current. Prefix was empty, so I call print anagrams with prefix was empty plus the current, which is in this case E, right? And then it calls with the word is going to be before plus after. So if you look into here, before plus after is equal to AST. Basically what it does is that it takes the first letter, concatenates it with the previous prefix, and then generates it as the new prefix and calls the recursive method with the new word. And then next time, for the second letter, it is going to basically call, again, print anagrams. This time it's going to be one of the other letters, which is going to be the next one. So current will be, when I is equal to 1, your current will be pointing to A, right? And then you will have here A. And then for the remaining part, before is going to be E. And then after is going to be ST. So it's going to basically create this new string. So basically what it does is that it gets the first letter and then the remaining is concatenated to generate the remaining part. And it's going to have, for the third case, it will have print anagrams with the third letter, which is S, and it will call the remaining part of the string, which is going to be AET. And the third one, the fourth one is going to be, again with the same with the same idea. You'll basically have the last letter T, and then you will have, for the remaining part, EAS. Okay? So, this is the recursive call. Since your loop goes from 0 to 4, you'll basically have it 4 times, as we did with the print anagrams. However, the next time, whenever you call this one, for example, let's say we do this, the next time it's going to be, the prefix is going to be E, and it will call print anagrams. How many times? It checks word.length, which is the second argument. So it's going to check for the second argument, AST, which is going to basically have the prefix E added to the current string. The current string is, in this case, what is it going to be? E concatenated by, if you look into this, what is the current string in the first call? It's going to be A. So you'll concatenate these two, call it as the new prefix, and then you'll get the remaining as the remaining part. So basically this is going to be equal to EA. Okay? And then the second call is going to be, since it will have three calls here, because it has three letters for the AST, it is going to be E and then the second letter S. The remaining part will be with AT. And then the third call is going to be, you will have E, this is prefix, that's going to be definitely there. And then you will have T, and then you will have AS as the remaining part. And if you go further on, in the next case, this is going to call itself twice, as we said before. So basically you're going to have, in this case, two print anagrams because it is two-letter word. Word.length is 2. In which case you'll call with the arguments EA and then concatenate it with the current letter S. And then this is going to be T, right? And then the second call is going to be EA. This is prefix that's going to be there. You will have T, and then the last part is going to be S, right? So if you do the last thing, this is going to basically go into the base case, which in this case will be print line prefix plus word. So it's going to print line. What is it going to print? East. And then similarly, this is the base case. It is going to print on the screen eats, and so on. So every instance of these, tree is going to print 1, and at the end you'll get something like a tree, right? Which is going to basically, this is the initial call with 4 letters and with prefixes E, A, S, and T. And then you will have here the new prefix EA and then ES, right? And here you will have ET. And similarly you will have 3 here, 3 there, and then 3 here. And each one will have 2, right? And then you will print 1 here, print 1 there. And if you count the number of leaves, you'll get 24 out of this. So if you look into here, this branch will print you 6 print lines, and then on each one of them you'll have 6 printouts as well. So it will print the total of 24 different strings. Okay? So again, this shows, although it's really simple code, as you can see, very basic, 4, 5, or 6 lines of code. However, it's powerful to print all these different combinations. Obviously, you can get this through an iterative method as well, but it's going to be a little bit more complicated and harder to understand if you try to write it. Any question? As I mentioned to you about the fractals we have seen before, what were the different fractals you have seen? If you remember this, what's the fractal? Koh's what? Snowflake, right? Koh snowflake, it was, kind of a snow shape that is generated by starting with a triangle. Similarly, you can generate really nice figures by using the recursion. If you look into Sierpinski's gasket, it's basically following the same pattern over and over if you go further inside the implementation. And it is composed of 8 smaller gaskets every time. So you basically have 1 gasket initial starting point, and then every time you generate 8 more, as it is shown here. So you see that this is the biggest square at the outermost level, and then you have a white square in the middle, and if you look into here, you see that you have 8 smaller white gaskets as shown there. So every time you go into one more level in the recursion, what you do is that you basically divide the outer square into 3 levels, 3 equal sizes on both dimensions, on x and y, and on each one of these, little pieces that you have. So you have 9 different, if you consider this as a grid, right? So you basically have divide the square into 9 grids, and then you have this as the center, and the remaining parts, the 8 squares, are used as the smaller gaskets. Okay, so you use this part as the new gasket, which is going to again divide it into 9 equal squares, and then each one of them will again divide, and so on and so forth. So it will basically, as you see, you have the innermost, and then you have one more level, and then another level, and then as you see these white little boxes, you have another level there. However, obviously you will stop at some point, which is going to basically depend on the size of the thing that you have. If this is really small, you won't be able to show anything. So this is again done using recursion, and you have the base case, which is checked for the 3 pixels. If it is lower than 3 pixels, it basically stops going further inside the recursion. So initially it starts with draw gasket 2020 and then 243. Basically it shows the coordinates and then the size of the gasket. So if you look into here, it says int x, int y, which indicates the coordinates of the gasket to start with, and then each side is given with the third argument. And if you look into that, this basically divides the side into 3 equal lengths, so that you have 1/3 for each newer gasket. And as you see, it has the new coordinates set to x and y, x plus sub. So you basically get, this is one of the new gaskets coordinate, this is another one, this is another one, and then you have here, there, this one, this one, this one. So you'll at the end get 8 different coordinates, x and y, based on the new sub values that is used there. So if this was initially x and y, you'll basically get here by x plus sub and then y, right? So this is basic coordinate system. And as you see, you get x, y, x plus sub y, and then all different combinations with the coordinates. And each sides of the new gaskets are going to be given with subs here. So basically, it first draws a rectangle, the innermost rectangle, which is shown here. This one is the innermost rectangle that is drawn. G rect box, new G rect, x plus sub, y plus sub, and then the sizes. So you draw this first, and then recursively, if this is greater than, if your new size is greater than 3, you basically call 8 draw gaskets, which are going to draw those 8 little gaskets on top of the current gasket. Okay? Any question? So let me go into another example, which is basically, let me just go into, I forgot to do that. Let me do this. So if you look into this, how do you think this can be implemented using recursion? This is basically a tree, right? So how can I implement this? Any idea? Base case you can think of obviously is going to be if you're below a certain size in the recursion, then you're going to stop. However, how does the recursion work here? Come on, you don't see the pattern? So every time, how many calls do I need to make in the recursion? So basically I will have this first line to start with, and then what do I do? It branches into two new routes. So one route goes this way and the other one goes this way. So basically I have two recursive calls at every step. If you look into here, I have two more recursive calls here. Here I have two more, and so on. So every time I will call for the left branch and right branch, two separate recursive calls. On top of that, do you see any other difference between the recursive calls? So there's the leaning is different from left to right. So for example, as you see, this one has a different behavior than the right hand side. So basically that's achieved by the angle that these 2 points are, aligned, right? So every time this one uses a different angle, whereas this one uses a different angle. Okay, so that's one other thing. And then also, if you look into the sizes of each side, can you tell anything about that? This one is smaller in terms of length, whereas this one is longer. So every time it uses a multiple of the original size. However, this one is multiplied with different constant, whereas this one is multiplied with a different constant. So if you look into the implementation, basically what you have is that the draw tree is a method which calls itself recursively, and it has the coordinates to start with the draw tree x0 and y0, and then you have the length to start with, how long is your tree's recursive step is going to be, and then the angle that you start with. So initially you start with draw tree 120 by 200, which is the coordinates of the starting point. So what you give into draw tree is that you give the starting point, let's say this is your starting point, x0 and y0, given with the two first arguments, and then you give a length and then an angle. Initially it starts with these coordinates, that doesn't matter, and then you have the size that is set to 50, and the angle is set to 90. So basically it generates new points, x1 and y1 at every step. How does it generate that? x1 is equal to x0 plus length times cosine degrees and the angle. GMAT is a library that is available, so you could just use it. And it gets the cosine degrees 90, which is going to give you, what is the result for that? Cosine 90? 0. So you get nothing for the x1 is equal to x0, and then y1 is equal to y0 minus 50. So you get to this point. Okay? And then once you get to the new point, you just add the new line, g line x0, y0, x1, y1. So you draw the line, this line. And then on top of that, you call two draw trees. Draw tree x1, y1, length times 0.75, angle plus 30. And then x1, y1, length times 0.66, angle minus 50. So one branch goes into angle plus 30, which is going to be leaning this way, right? And then the other one is going to let you lean towards this direction. And then obviously, since you're multiplying 1 with 0.75 with the length, it is going to have a smaller size compared to the original one, and this is going to be even smaller. Okay? So as you see in the next call, when you call it with x1, y1, so this is going to take this as the new origin point, and then we'll calculate the new x2 and y2 points based on this, the cosine degree and the length. Every time it will just update the x and y values, and according to that it will continue doing the same thing until this length is greater than 2. Obviously it will get decreased every time, and you can calculate the number of steps that you're going to go further. Okay? Any question? So this is about the recursive, GUI type of examples. I'd like to do first of all the quiz question that I asked last time. So what was the quiz question? So let's say you're given a string public, string reverse, and you're asked to get the reverse of the argument that is passed to the method, right? String str. So how am I going to reverse this string str? Basically, you will first write the base case, right? If str.length is equal to 0 or 1, you can say less than or equal to 0, or you can less than or equal to 1, sorry. You'll return str. Else, so let's say I have cat, I will basically recursively call the same method. How can I call it recursively? You could call it with ca and then divide it into two halves, and consider t as the only string and reverse it and put it on at the beginning, and then call the reverse for the remaining part, right? So you can do it in the other way as well. So you can start with the left part also. So else, what am I going to say? Return str charet str.length -1. So I got the last character. I will put it at the beginning, right? So I got this character, and then I will say plus, and I will call reverse so I will get the remaining part, which is this part. I got t at the beginning, and then I call reverse ca. Now I will call it in this manner, which is going to just call reverse str dot substring, right? And then, so basically I will go 0 from str dot length -1, right? It is not going to take the length -1, the last entry, which is going to basically be true. So it will include all the way to t, except t, it will get ca, and this is going to return you the reverse of the string. Okay, any question? So let me ask you another question. So if you were to write the number of the count of the digits in a given number, meaning that, let's say I give you, you write me the method with the arguments. Let's say I give you 1, 3, 4, and then 6, 1, and I tell you 1. You tell me the number of times 1 appears in the number. So the digit appears in the number, how many times? So it's going to basically return you, in this case, 2. Since 1 appears twice, it will return you 2. You're supposed to write this in a recursive manner. How can you write it? So let's say what am I going to return? Public int, so that I will return an int value, and then let's say count digit, and then I have the number int num, and then I have int digit. So how are you going to compute this? So first of all, what's the base case?
If digit is equal to num.charet length,
both of them are integers. So this is given as an integer, and this is given as an integer as well. However, this is, that it is within the digit limits 0 to 9.
Şu number'ı string alsak daha güzel.
Formülü içinde olan
Yani string girsin. Daha işlem yaparız sanki.
You are given it like this. No string operations.
Hocam ondan az dersek
So the base case is going to be every time you need to get one digit to compare, right? So you need to get one digit that's going to be the final case or base case of your recursion. So in which case you want to, if you want to check whether n or number divided by 10 is equal to 0. If it is 5, for example, it's going to be 0. If it is 3, it's going to be 0. If it is 2, it's going to be 0. Until, if it is not greater than or equal to 10, it will be 0. Or you can say, if number is between 0 and 9, you can say that too. That's okay. However, that's also going to give you whether the number is between 0 and 9. If this is the case, then what am I going to return? Return. I will return 1 if it is equal to the digit. Otherwise, I will return 0. So I can say return number equals digit. If they are equal, I will return 1. Otherwise, I will return 0. Else, if this is not the case, if I have, let's say, more than one digits in my number, let's say 65 or something like that, what am I going to do? I will check for this number, let's say 165. I will check for this number and then rerun my same method recursively with the remaining part, with 16. So how can you do that? So what I'm doing with this example is going to be, you have 61 and then you will first check this and run the same thing with this new number. And then the next time you'll check with this and then run it with this new number. And then check with this and then run it with 13. And the next time you'll check with 3 and run it with 1, which is going to be the final case. So how can you write it? Return. What am I going to return? I need to check the rightmost digit. How do you check that? So you'll get number remainder by 10. So that gives you the rightmost digit, which is going to be 1. Exactly same as we did here. I'll get that if it is equal to digit, which means the rightmost bit or the number, the digit is equal to the given digit. If this is the case, it will give me 1, otherwise 0. So this is going to be either 1 or 0. And then on top of that, what am I going to call? And then I will add one more thing, which is going to call the recursive method count digit. So now the new number is going to be only this part, which is going to be num divided by 10. So you get this number, 1348. And then you'll pass the argument as same before as digit. Okay? Any question?
Hocam count nerede abi?
What do you mean?
I mean if there is 2 times 1, how we can understand?
It's basically counted by this. So initially it's going to, the first time you call this, it's going to call you return, whether this is 1 or 0, this will give you 1, right? Plus whatever is returned from this part. So it will return here as 1, so that you'll add that 1 to get 2. Okay. You can use any operator such as AND, or let's say you have a Boolean result that you're going to generate. You will obviously use AND or OR to generate the recursive method for the Boolean result, as we did with summation for counting the things. So if you are to find the remainder of a division, again, this doesn't make sense to write it recursively, but just for fun of it, we are going to write. So if I have a numerator and then I have a denominator, let's say int n, int d, and I'd like to calculate the remainder, let's say 165 divided by 16. What's the remainder for this division? You can get this by just the percent operator, right, to get the modulus, which is easy. However, if you're not allowed to use that operator, how can you do it recursively? It's going to be obviously not count digit, the remainder. So, what's the base case? When are you going to stop? Whenever your n is less than d, such as let's say 13, 16. So this is going to be where you're going to stop, because this is going to be the remainder. So you'll check n, compare with d. If it is less than that, if n is less than d, you're going to return n. Else, if they are equal, what are we going to do? We will return 0. Else, if n is equal to d, we will return 0. Else, so we're back to the recursion step. What are we going to return?
Has to divide recursively.
Recursively to what?
Divide.
When you divide, what do you get?
It will get smaller and smaller until there is a remainder.
But division is not going to get you to the remainder, right? What do you need to do? Return. I will call remainder. Basically, if you subtract the remainder, the denominator from the numerator, you're going to get to the remainder, right? So you'll call it with n minus d, and then d. Okay? Any question? Are you tired of recursion? Okay. Let's say you're asked to find the binary converter. So if I give you let's say a number 52, for example, and I ask you to convert this to the binary form, what's the old school math? So you just basically divide it by 2 every time, right? And then you get 26, 52, and you get 0 from here. And you divide it again with 2, which gives you 26, again 0. 2, 12, you get 1. 2, and then you get 6, 0. 2, and then you get 1, and you get 1 here. So you get the binary correspondent of the same value by just doing it in the reverse manner, which will get you to 1, 1, 0, 1, 0, 0, right? So how can I get this? By recursion. So the method is going to be something like this. Public I will get a string which represents the binary form of the result and binary converter, and I'll give an integer n. So what's the base case? We can do that. Or you can write it while you're returning the string. So if, what's the base case?
N equals to 1.
If n is less than or equal to 1. What are we going to return? Return n. And else, what am I going to return? Obviously this is not going to be just n, since it's a string, right? Not an integer. Else, what am I going to return? Return So what do you do normally? You every time divide it by 2 and then use the remainder and concatenate it. So whatever is generated from this part, I'm going to use it as the starting point, and then I'll concatenate with whatever is here. What is this? This is the remainder. So you basically get this is the remainder I concatenated at the end, and I will append this to what? So whatever is returned from here, which is going to be binary converter, and then what will you have? N over 2, the new number, which is 26, and obviously you'll have a string concatenated, which is not going to be with space, so that it performs a concatenation instead of an addition. Okay? Any question? So basically what you do is, you identify what is the purpose and what would be the each recursive step. In this case, you understood that this is going to be the last digit that you're going to append, and that's why you used as the the recursive steps addition, and then on top of that you call the recursive method with the new value, which is this 26 generated as a result. Okay, let's give a break and then we will continue after this.